Hi, I'm Chris Dorsi. I'm here with Saturn Online to perform an assessment of this house. Type of measurements we're going to make are the kind of things you need to do if you're going to be inputting information into REM rate, REM design, treat, or some other sort of assessment software. Let's look a little bit closer. So while you're measuring the exterior dimensions of the house, you also need to be looking for different types of walls. You may have a different R value in different parts. There may be an original house that's got additions added to it. You'll have an opportunity once you're inside the house to be able to probe behind cover plates or behind electrical panels and get some idea what the insulation material and thickness may be in those areas. But oftentimes at the outdoors, you'll get the first hints of those different wall types. Be sure to note those on your forms. And if you do see they're different, you may have different wall sections. Wall section number 1, wall section number 2, and wall section number 3, for instance. Finally, as you're standing at the front of the house, as we are here, you need to take a compass bearing, because most assessment programs will use that information to estimate the solar gain in the various windows. So I'm standing with my back to the front door facing the street. I'm going to hold the compass at right angles to the house, and I'm going to adjust the bezel until the red arrow in the bezel is directly underneath the red arrow of the pointer, because those point north. And the reading we're taking is directly away from the house, which is the white end of the needle. And in this case, the front of this house has a compass orientation of 190 degrees, or almost due south. So I got 19.6 plus 1.7. With complicated structures like this, you have to keep a very good set of notes, because you don't want to get back to your truck or back to your office and discover later you don't have all the information you need.
Transfer your measurements to a set of dimensioned sketches or photos, or enter the measurements into your energy auditing software.
For this kind of work, I always work with 2 tape measures. I got my favorite 100-foot tape measure and a standard 25-foot. We're going to take the horizontal measurements of the building from the outside, and the vertical measurements we'll always take from indoors. While I'm measuring the outside of the home, I'll also need to look at the foundation to determine how much of it may be exposed. At this stage of measurement, I don't yet know the height of the foundation wall, because I'll determine that once I get down into the basement. But at the wall I'm looking at right here, on the right or south end, there's about a foot of wall exposed above the grade level. And on the left or north end, there's about 3 feet exposed above grade level. So for this particular piece of foundation, I'm going to enter it in the software as having an average of 2 feet exposed above grade. And then I'll complete the information about the total height of the foundation wall once I get into the basement and take a look at it.
The goal of making drawings or annotating photos is to get all the information you need for the energy audit, proposal, or work order. The amount of information you collect depends on your knowledge of whether the home will be retrofitted or not. If you'll produce a work order, the drawings will be a big help. The floor plans give you the ability to calculate attic and floor insulation, as well as the home's volume for blower door calculations. These elevations identify the directions that the walls face, give you the wall surface area, and locate the windows. They also show the foundation wall area above grade.
Okay, now I moved inside the house. This is where we'll take the vertical dimensions from all the walls, and we'll measure from the floor up to the finished ceiling. If we've identified different wall types at the outside, we'll have to take a different vertical measurement for each one of those wall sections. For this particular wall section, we're going to measure in inches. And it's 102 inches from the finished floor to the finished ceiling. We've identified just one type of wall section, and here I found an existing hole in the house. Actually, it was damaged here where I can use this borescope to look inside and assess the insulation level. This is a great tool. They're worth, $100 to $400 for different versions of this tool, but it lets you look inside cavities without having to make too big a hole. I'm going to look through this hole and determine what kind of insulation is in here, but I'll also do the same thing in 2 or 3 other places throughout the house. The tip of the probe is lighted, and I can get a surprisingly good view of what I suspect what is in there, which is about a 4-inch cavity full of loose-fill cellulose insulation. Yep, I'm certain that's what it is. Okay, so I'll note that in my records, and I'll go throughout the house and find a couple other places that confirm, but I believe that this entire house is going to have the same wall section throughout. I've located an attic inspection hatch, and I brought my sturdy 6-foot ladder. My primary interest is to look at the attic insulation and assess its type and thickness so I can calculate its R value. But I'll also be looking at some other building systems while I'm up there. I'll be looking for any deteriorated electrical wiring that could be dangerous to me or to the occupants of the home. I'll be looking over the plumbing venting system for any leaks or disconnects. I'll be looking at the attic ventilation to make sure that we don't have a moisture accumulation problem, and I'll especially be looking for any signs of mold and mildew in the insulation or on the back of the roof sheathing. But as I do this attic inspection, I'm also concerned about my own safety. So I'll be looking to make sure I don't knock my head on nails that stick through the roof sheathing. I'll be careful that I step only on the framing and not on the back of the sheetrock, and I'll be looking out for the creatures that sometimes live in attics. Because I don't like going into dark places without knowing what I'm seeing, I always bring my headlight for these kinds of inspections. Up in the attic, I've got a comfortable place to sit up in the trusses. I'm going to watch that I don't bash my head on the roofing nails which are sticking through the sheathing up above me. First thing I'll do when I get up here is take a broad pass and look around the attic and try to decide what type of insulation that's up here. In this case, we're looking at cellulose. I'm also going to dig down near the attic hatch here all the way to the bottom of the insulation and make sure there's not a layer of something else installed underneath it. It's pretty common in older houses to have a layer of silver wool or mineral wool perhaps that was installed initially, and then a younger layer of cellulose or fiberglass installed over top of that. I'm trying to determine how thick the insulation is so I can calculate the R value. In this older house we have single glazed double hung windows with single glazed storm windows as well. If this were a newer house, I'd also be checking for a low-E coating. Next, I'm going to measure the rough openings of all the doors and windows. I've developed a window schedule which starts at the front door and works around the house clockwise. This particular bank of windows here are numbers 7, 8, and 9. I'll measure width and height in that order, and I'll measure them in inches. We're always looking at the rough opening, and it may take a little bit of understanding of construction to recognize where the rough opening may be. With this particular old double hung window, there's actually a weight cavity on each side. So I know the rough opening is about 3.5 inches back from the inside of the finished jamb. So for this particular window, I'm going to register a rough opening dimension of 26 inches. And for the vertical dimension, we don't have weight pockets, but we'll give it at least an inch on either side for the framing. So for this particular window, we're going to measure 57 inches in the vertical dimension to the rough opening.
Making a window schedule is an essential part of the energy audit if window retrofit is part of a work order or a proposal to the customer. For storm windows or window replacements, the measurements must be quite accurate. You list the window size, width first, then height. For a replacement window, you'll need either the rough opening size or the frame size. The rough opening is the width and height of the framed opening. For a storm window, you'll need the dimensions of the opening where it's installed with the correct clearance factored in. Make a checklist of necessary information depending on the purpose of your energy audit. Carry the checklist with you and use it. Finish your measuring and recording at the building if you have time, because during your recording process you may discover that you missed some information initially. Mark linear dimensions, areas, and volumes on the drawings. Don't hurry your information gathering unless you have to. It's frustrating and inconvenient to find yourself back at the office finishing your energy audit, proposal, or work order without all the necessary information. Remember to ask whether the building you're auditing has as-built plans. Blueprints can save you a whole lot of work. With multifamily and commercial buildings, as-built plans are often available. Many energy auditors tend to skimp on planning and information gathering. This neglect can reduce the accuracy of the energy audit, or worse, waste time and money during the retrofit job. Check and double check your information and record the information neatly. Your colleagues and customers will thank you for your thoroughness and clear communication in your energy audits, proposals, and work orders. Photos have become a staple of energy auditing since digital cameras and smartphones became available. If you don't have time to make drawings, consider taking photographs and labeling them with the necessary information. You can label photos in the photo processing program or print the photos and label them on paper. Take photos of damaged areas where the crew will work so they don't get blamed for the damage. Take before photos of areas that will be retrofitted. Record health and safety problems with photos. The disadvantage of photos for measurements is that you need a computer and photo processor or printer to complete the visual information record. This requires a good paper form or a form designed for a laptop or tablet. Time is money, so make sure that you arrive at the energy audit with a good process for taking measurements and recording them clearly and efficiently. If you're fast at recording information on a laptop or tablet, use these tools. If you're more comfortable and efficient using drawings and paper forms, don't hesitate to use these time-worn procedures.